Welcome back, and now we will discuss what is called as a full subtractor. Actually, in a full subtractor what we have is we have 3 bits and the output is represented in 2 separate bits given by borrow and subtract. Fine. But before that, you should remember that in subtractors we represent the numbers in 2's complement, and if I have to represent 1 in 2's complement, I represent it by 0 1. Let's say I have to represent it in 2 bits. If I have to represent 0, I represent it as 0 0. If I have to represent 2, in fact minus 2, I represent it as 1 0, and if I have to represent minus 1, I write it as 1 1. So these are the 4 things which we have to remember. Okay, this should be in your memory. Now the input combination can go like this: 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1. Fine. So because 0 minus 0 minus 0 is 0, I have to write 0 0 as answer. 0 minus 0 is 0, and then 0 minus 1 is minus 1. Minus 1 is represented by 1 1 in 2's complement. So this is a convention, this is a declaration, this is an agreement between you and me that we are representing the numbers for full subtractor output in 2's complement. This also will be minus 1, this also will be 0 minus 1 is minus 1, minus 1 minus 1 is minus 2. Minus 2 is represented by 1 0. 1 minus 0 minus 0, 1 is represented like this, 0 is represented like this, 0 is represented 0, 1 minus 1 is 0, 0 minus 1 is minus 1 is represented like this. Okay, so this is the truth table or the logic table. Now we will have to check what is f borrow and f subtract, and we can write it as the sum of minterms. So अगर f subtract का sum of minterms देखें तो it would be m1 plus m2 plus m0 1 2 3 4 m4 plus m7 1 2 4 7, and then we have for borrow it should be m1 plus m2 plus m3 plus m7. Okay, and the next task is absolutely to first write down the equations. So f sub will be a bar b bar c plus a bar b c bar plus a b bar c bar plus a b c. Okay, and doing the same thing as we did for full adder case, you will find that taking a bar common from these two and a common from these two, you will just simply get that the answer should be a XOR b XOR c. So the f sub is same as f sum. So a XOR b XOR c. Now what we have to do is we have to check for what will be the function of f borrow. And to do that, m1 2 3 7. So this is f borrow is equals to m1, which is a bar b bar c, plus m2, which is a bar b c bar, plus m3, which is a bar b c, plus m7, which is a b c. Okay. Now from these where a bar, we have a bar b and a b bar, we have a bar b bar and a b and a b. So from this and this we can take c common, a bar b bar a b c common, and from the middle two you can just simply write it as a bar b c bar plus c. So this becomes what? This becomes a XOR b bar dot c plus a bar dot b, because c plus c bar is 0. So this is the final expression for f borrow. Okay. Now if you want to make or draw an output for f subtract, it is pretty easy. That we just want XOR and XOR gates. So let's say this is A, this is B, and this is C. Then F subtract is given by A XOR B XOR C. But then we have to make for F borrow. And F borrow, what I can take is I can first take this thing, which is A XOR B, take a knot of it. I've taken knot of A XOR B. I can take AND of this thing with C. Okay. Also, I can take A, take a knot of it, and take AND of this thing with B. And the output of these two will go and merge in another OR gate. So this will be F carry. Fine. So this is the circuit diagram for full subtractor or 3-bit subtractor. So we have to just make a 3-bit subtractor. So we need NOT gates, we need AND gates, we need XORs, and we need an OR. Remember, earlier the circuit which we made, which was of a full adder, it's simply like as if in the full adder I have put a NOT gate here and a NOT gate here. देखिए, it's similar. एक NOT gate A के बाद और एक NOT gate A XOR B. देखिए, इसका एक्सप्रेशन था A plus B dot C plus AB. इसमें यहाँ बार लग जाए और यहाँ बार लग जाए तो it will become a subtractor. So this is all what we have to do, and the same thing I have done in my circuit also. So I think I can remove it. You can take a screenshot of it or pause the video for a moment and draw the circuit. So yes, I have to be a bit careful because the circuit is quite more complex now. Yes. So this is it. This is what I have done. This is 7486 IC, 7404, 7408, 7432, and these are the 3 inputs, and यहाँ जो है 2 outputs लगाए. ठीक? I am running out of different colors, different colored wires because you guys are visiting college these days and you are using, not the BSc students, but at least the BBook students are utilizing the resources to its full. Fine. Now what we have to do is we have to just verify the truth table. So the truth table is this. There it is. Yes. So let me just put the truth table on this side. Let me fold it a bit more so that I can accommodate it properly. This is the truth table. Okay. Do I need to fix it using some panel? I can fix that also. It seems fixed now. Much better. So we will start by giving 0, 0, and 0. Make sure when you are changing circuits over here or inputs over there, you should not be making any change in middle or in between these circuits. Otherwise, you will not be able to find out where you have done a mistake. So I've given 0, 0, 0 everywhere. Let's say what is F sub. Oh, it is running out of. So my F sub is 0.00 and F borrow is also 0.00. So my first thing is verified. All 0, it's 0. Now I will give only the last input as 1. My C to be 1. Okay, so I have fixed my last input to 1. Let us check. A is 0, B is 0, and where is C? C is somewhere there. Yeah. So C is 5.23, means I have made my last input to be 1. Let's check what is going to be the output. So the output now will be, write down for sub, F sub is 5.23 and F borrow should also be nearly 5.23. So you see, we want 1 and 1. So this is also verified. Now I will make C equals to 0 but B equals to 1. So this was C and this is B. I made B equals to 1. So you can check A equals to 0, B equals to 5.23 and C equals to 0.00. My answer is I'm expecting it to be both 1 1. So 5.23 as f sub and 5.23 as f borrow as well. So far our circuit is going well. Now, so till here we have checked. Now we have to check for 1 1, 0 1 1. It is we are expecting for 0 1 1 it should be 1 and 0. It means 0 as sub and 1 as borrow. Let us check. So I've given 0 1 and where it is, yeah, 1, and the answer is 0 as f sub, fingers crossed, and 5.23 at f borrow. So this also has been verified. Actually, when you will be performing the experiment, actually this is the most critical output, and usually the examiner will try to test this only, because if your circuit is functioning well, every gate is working well, then this will be the answer. अदरवाइज बाकी सब हो सकता है वेरीफाई हो जाए, लेकिन ये वेरीफाई नहीं होगा. इसके लिए नॉट गेट, एंड गेट, और गेट सबका चलना जरूरी है. ठीक है. ओके, नाउ व्हाट आई विल डू इज आई विल हैव टू स्विच or fixed my A to 1 and B to 0, B and C to 0 0. Okay, it is fixed to 1 and B and C are to be fixed to 0 0. So I have made this to 1 0 0. Let us check. A is 1, A is 5.23, B is 0.00, and C, where is C? C is there, 0.00. 100 पे I am expecting F sub to be 1, yes, 5.23, and F borrow to be 0. It is exactly the same. ये भी verify हो गया. Now I have to give 101. Now this is 101. In case 8 में से कोई एक का आउटपुट भी गलत आ रहा है, तो इसका मतलब आपका सर्किट गलत है. इसीलिए we have to verify all 8. That's why I'm including it. You can increase the speed of the video or you can skip few parts. But अगर किसी एक का भी आउटपुट अगर गलत आएगा, then we have to check कि सर्किट कहाँ गलत हुआ. Okay. So I have now given what? 101. This is 1 0 and 1. 101 पे क्या आउटपुट आना चाहिए? It should be both 0 0. F sub is 0, F borrow is 0. तो दोनों 0 0 आ रहे हैं. ये भी बहुत क्रिटिकल है, ये भी नहीं आता है कई सारे स्टूडेंट्स का. ये 0 है and this also is 0. ठीक है. फिर आते हैं 1 1 0 करके देखते हैं. 1 1 and 0. So now we will check for 1 1 0. Let's check. A is 5.23, B is 5.23, and C is 0.00. Answer is expected to be 0 0. Let us see. F sub is 0, F borrow is, let me check, F borrow is 1. So now we have to see, because I gave both as 1 1 0, whether this was 1. Okay, that's fine. This is 1, this is 1, and this is 1 minus 1 equals to 0, so 0 should be 0. We have given this as, we have to check it over here. This is coming out to be 0, this is coming out to be 1, and you have to just check why this is coming out to be 5. So we will back propagate. Back propagate का मतलब देखते हैं इस IC में जो और की IC है इनमें से कोई एक चीज 1 आ रही है. So actually what is happening over here is this is my A dot B, the answer is coming out to be 5. So my IC for AND gate has actually stopped working properly, because 0 and 5 should give me an output 0, not 5. So अगर एक भी गलत आया, as I told you that you have to just check क्यों गलत आ रहा है. I have to remove this IC. First switch off. I have to remove this IC. This is 7408. Perhaps the gate may not be functioning properly, or the breadboard is broken from that particular part. It is 7408. Carefully I will drop and connect the IC with utmost care because this portion is extremely complex. Yes, I did it. Turn on. I've turned that on. Let me just check for 0 and 0. For 0 and 5, my answer should be 0. Now it will be 0. Yeah, you see. I got it. इसका मतलब बाकी सारे जितने outputs आ रहे थे, those were working because that particular portion of the gate was not needed. So it means like the one which we verified earlier, it was not needing, it was not required to be like that IC to be working. But as of now, if we have figured out that this IC is now working properly, you should reiterate the whole process. यहाँ से फिर से शुरू करना चाहिए. That I'll skip for my part because I just have to verify whether for 1, 1 and 0, I'm getting 0 and 0 or not. So I'm getting 0 and 0, so this works fine for me. Now I'll connect everything to 1. So सब कुछ 1 कर दिया. सब कुछ 1 करने पे आंसर आना चाहिए. You see, I have connected this to 1, this to 1, and C also to 1. Answer should be 1, 1. Let's see. It is F subtract is 5.23 and F borrow is 5.23. So all verified. ठीक है. लेकिन याद रखिएगा एग्जाम में अगर रैंडमली एग्जामिनर ने आके आपसे पूछा कि मुझे ये वेरीफाई करके दिखाइए और आपने कहा कि बस इसको छोड़ के सब वेरीफाई हो रहा है, देन यू आर रॉन्ग. यू हैव टू वेरीफाई इट विद करेक्शंस जो भी किया स्टार्टिंग फ्रॉम हियर एंड देन एंड हियर. ठीक है. सो आई न्यू परहैप्स that that particular AND gate was not working properly, but as an example I have to keep it. ठीक है. So this completes your full subtractor also. Now we are left with only the analog part in which we have to design a power supply using Zener and we have to use diode as rectifiers. That's it. 3 more experiments to do. Thank you so much all of you.